So does anyone want to share their answers here? So the first, oops. So the first set of questions asked about the results that we received as a part of the study. So basically the pathology results gave us some of the metabolite levels, such as glucose, pyruvate, NAD+, and NADH. And then they gave you the patient's level. So the patient, so just to kind of remind ourselves here, jog our memory, the case study we're talking about had to do with 7 victims. They had suddenly passed or suddenly died living in a close proximity around a similar time period. And so the officials here are investigating what could be the cause, what could be the common theme that is seen among these 7 patients. And so looking at their autopsy, we saw one big discrepancy. We saw that although they had perfectly normal oxygen levels, the cause of death was hypoxia, which is lack of oxygen or suffocation. And so that was the first kind of, odd thing about these 7 patients. And then I gave you this third part of the case, which talked about the metabolite levels. And what we see was that there was damage to the ATP, damage to the cells, and the ATP levels were extremely low, right, in the mitochondria. So not a lot of ATP being made in the mitochondria. And then looking more closely at these levels, we also see that, okay, glucose is normal pretty much, pyruvate is also normal, but when we look at the carriers, we see a bit of a discrepancy, okay? And so the first question asked to list out whether these were substrates or products, and then their main function. I'm not going to get too much into the details here. You should remember that glucose, we talked about it being a substrate for glycolysis. Pyruvate was a product of glycolysis and then a substrate for the linking step. And then our carriers, NAD+ was a substrate for glycolysis, the Krebs cycle, as well as so glycolysis, the Krebs cycle, the linking step. And then NADH was a substrate for the electron transport chain. Okay, so just to kind of jog your memory from what we talked about. The question that I really want you to be able to answer here is, what are some hypotheses you have about why there's a discrepancy in the carrier levels? So we see that NAD+, the patient levels are extremely low, so about 10 micrometers. And then the normal levels are about 75. So extremely low NAD+ levels, and then extremely high NADH levels. So this should be the reduced form, and this is the oxidized form. So I'm really specifically interested in some of your thoughts and you sharing what you think could be wrong to result in these abnormal carrier levels. So any thoughts or ideas, any hypotheses?
The electron transport chain, is it working?
Okay, great, thank you. So Caitlin said the electron transport chain is not working. And that is an excellent conclusion or an excellent first guess, because we know that the electron transport chain uses NADH. We just said that NADH is a substrate for the electron transport chain. And then we said that NAD+ is going to be a product of the electron transport chain. So if we have low levels of the product of the electron transport chain and high levels of the substrate of the electron transport chain, then we can come to the conclusion that there's something wrong with the electron transport chain. We're not getting the NAD+, we're not getting the oxidized form of our carriers back at the end of oxidative phosphorylation, and we're not utilizing the substrate, which is these electrons being shuttled in on NADH. So that's an excellent conclusion. And I think we understand why, right? So if we have a block, we're going to have a buildup of our substrate, and a decreased level of our product. Okay. And then jumping to the fourth part of the case, it revealed here at the end that we're now convinced that the cause of death for these victims, and we quickly report it back to the police. This is a very dangerous situation. After realizing that the electron transport chain was no longer functioning, you then start to suspect poisoning and run blood tests for various poisons that you know affected the electron transport chain. The test of all 7 patients come back positive for cyanide. Cyanide irreversibly binds to cytochrome C oxidase of the electron transport chain and prevents transfer of electrons to oxygen, which is the final electron acceptor. So all of that to say, we suspect problems with the electron transport chain, and so we run the adequate lab test, and it comes back positive for cyanide. Now, cyanide is a very deadly, very fatal poison. It was actually invented around World War II, I believe, as a suicide poison. So the soldiers, when they were captured, they would just swallow this pill and they would immediately die. That's how fatal cyanide was designed to be. And we can see why. It immediately influences this complex. So cytochrome C oxidase is one of the complexes that is inserted in the mitochondrial membrane that is helping to pass these electrons along. And so if we block or eliminate one of these carriers from passing electrons, we essentially bring that chain to a halt, right? And so oxygen builds up because oxygen is not the problem. Oxygen is standing by to grab the electrons, but they're simply not being shuttled along and making their way to oxygen. So there's no problem with oxygen itself, but the problem is with the movement of electrons along the chain. And so if we build up the electrons, we don't get our hydrogen ion gradient, which is that gradient across in the intermembrane space. We don't get those ions moving down ATP synthase. Let me go here to kind of explain here. So we don't get the hydrogen ions moving down ATP synthase, and we don't make ATP, okay? We don't make ATP, we die. So this is how cyanide is fatal, by affecting, by design, the movement of electrons across the electron transport chain. And as a result, it halts the synthesis of ATP. And so cells are no longer able to make energy, and so they die, okay? Any questions on the events of the case study, the activities, some of the answers, any questions? Or anything additional anyone want to share? Okay, so this is an actual real event that took place in Chicago where 7 people were murdered. And these were deemed as murders because there was intentional tampering, intentional poisoning. There was Tylenol, so over-the-counter Tylenol was replaced with cyanide. And so these patients all before death complained of a headache or some type of pain, took this Tylenol, and then they expired immediately because of the immediate fatality of this cyanide. So kind of interesting case and interesting connection to our topic, which is the electron transport chain.